Okay, this is lesson 3.5, dividing polynomials. In order to divide polynomials, we use a process that's very similar to the process of long division that you learned in elementary school. So in order to do polynomial division properly, we need to first recall the skills from long division. So I have a concrete example here that's completed with some terminology. So we'll go over that really quickly and then we'll try an example. The number that you are dividing is called the dividend, and the number you're dividing by is called the divisor. The answer to the division question is called a quotient. The answer, if you take the quotient and multiply it by the divisor, you should come out with the dividend. At the end of the process, if there is a number left over, it's called the remainder. So let's try some long division. We take our divisor and we look to the very first number in the quotient. We see if we can divide that quotient by the divisor. So the question, divide that dividend by the divisor. So that first step would be, can we divide 4 by 21? And the answer to that is no. We can't, so we move over one more space and we look at the next two-digit number, 48, and we ask ourselves if we can divide 48 by 21. And if so, how many times? Well, the answer would be 2, because two 21s fit in 48. So we write a 2 on top, and then we multiply across and down. 2 times 21 is 42. We subtract 42 from 48 to see what we're left with, which is 6, and then we bring down the next digit in the dividend, 7, to make the number 67. Then we ask ourselves, how many times can we divide, or how many 21s fit into 67? Or can we divide 67 by 21? And the answer again is yes, we can. And it's 3 times. So we do 3 times 21 would give us 63. And then subtract down the column. 67 minus 63 is 4. So we'd have a remainder of 4. I guess that arrow is drawn in the wrong spot. Ignore that. So let's try it to practice one. We'll try to divide 526 by 3. So we'll start by writing our divisor 3. Our dividend 526. And we'll start the process. Can we divide 5 by 3? The answer is yes. How many times does 3 fit into 5? The answer is 1. 1 times 3 is 3. Subtract, we get 2. Bring down the next digit, 2. Can we divide 22 by 3? Yes. The answer is 7. 7 times 3 is 21. Bring down the next digit. Subtract first. 1. Bring down the next digit. 6. Can we divide 16 by 3? Again, yes. 3 goes into 16 5 times. 5 times 3 is 15. And subtract down the column, we're left with 1 remainder. The division statement for this question would say if we took 526 and divided it by 3, the answer would be 175 with 1 remainder. And that 1 remainder represents 1/3. Because it's not a whole. If it was a whole, we'd be able to divide evenly. It's 1 divided by whatever the divisor is. So it's 1/3. If the remainder was 2, it'd be 2/3. There wouldn't be a remainder of 3 because that means we'd have enough here to actually go in 6 times. So it's always 1/3. Another way to write that division statement is that 526 is equal to 3 times 175 plus the remainder. Okay, 2 different ways to write the division statement at the end. So how do we apply this to polynomial division? Well, it's very similar. If we wanted to divide a quadratic, 4x squared minus 11x minus 3, by a binomial, x minus 3, we'd set it up the exact same way. X minus 3 is our divisor. Our dividend is 4x squared minus 11x minus 3. And we start by asking ourselves, how many times can x minus 3 go into 4x squared? And this is very similar to when you're trying to divide 21 or 2 items into 1 item, 4. It won't fit. If you have 2 items or a 2-digit number or a 2-term polynomial, you have to divide it into another 2-digit number that's bigger, or in this case, a 2-term polynomial. So you can't divide a 1-term polynomial by a 2-term polynomial. So that would go in 0 times. The next part, how many times could we divide x minus 3 into 4x squared minus 11x? The answer to that question is 4x times. And here's why. When you multiply across and bring down, watch what happens. 4x times x gives you 4x squared. 4x times negative 3 gives you negative 12x. So how did I know that x minus 3 would go into 4x squared minus 11x 4x times? The key to picking the number that becomes part of your quotient is taking the first term of your binomial, 4x squared, and dividing it by the first term of your monomial or your binomial divisor, x minus 3. So that's taking 4x squared and dividing it by x. And that is 4x. The reason we do that is because we're always trying to build to the first term. We're always trying to build to 4x squared, and the way we can do that is by making the first part of your quotient 4x, because 4x times x is 4x squared. You're always trying to build that first part when you're building your quotient. So if we subtract down the columns now, 4x squared minus 4x squared is 0x squared. Negative 11x minus negative 12x is positive x. Okay? The reason we're always trying to build that first term is because we're trying to chip away at the polynomial that we're dividing. And if we can make it go in evenly, or force it to go in evenly, that first term will always subtract to 0, and will always be reducing the polynomial that we're dividing. Okay? Next step, bring down the last term, minus 3. Now we have x minus 3. So the question is, how many times will x minus 3 go into x minus 3? The key here is, again, to build that first term, x. So something times x gives you x. And in that case, it's 1. We don't worry about the last terms. That's how we build our remainder, and then we keep tacking on as we're continuing to divide our polynomial. And it's okay if it works out with the remainder. So 1 times x is x. 1 times negative 3 is negative 3. We got the exact same binomial, so if we subtract x minus x, we get 0. Negative 3 subtract negative 3, we get 0. So we have a 0 remainder. That's our first division of a polynomial that we've ever done. I'm going to do one more example, but first I'm going to write what's called a division statement. And you can write a division statement in 2 ways. You can follow this pattern down here, so I'll do that one up here. Divisor. The divisor is the first part, x minus 3, times the quotient, 4x plus 1, plus the remainder, 0, equals the dividend, 4x squared minus 11x minus 3. This is a polynomial. This is an equivalent polynomial. What you might notice about these two forms is, well, this looks an awful lot like standard form, and this looks an awful lot like factored form, and that's because it is. This is factored form. Next lesson, we're actually going to use polynomial division to factor. And the way we factor is we look for divisors that are going to give us a remainder of 0. If the remainder wasn't 0, we'd have a plus here and a number, and then it wouldn't be factored form anymore. So the way we factor is by looking for remainders of 0, and that becomes a very important concept in the next lesson. A second way you can write the division statement, or an alternate, is you can write exactly what the division was. It was 4x squared minus 11x minus 3, and we divided it by x minus 3. And then we can write what our answer was. Our answer is our quotient, 4x plus 1, plus any remainder. And in this case, we don't have a remainder, 0, so it would be plus 0. So here's another way to write a division statement. Either way would be acceptable. We'll title that division statement. So what I get you to try to do now is try your own division question. Divide this polynomial by this divisor, and then check your answer to see if you did it right. That's it for the first part of the video. In the second part of the video, we'll do another polynomial division question, so you get to see a little bit more. And it'll be very similar to the example we did, but a little bit more challenging. Okay, so try the practice first, then watch the second video. Thanks for watching.